So 3.6b, and we're going to do rational inequalities here, and this basically just means we're going to do fractions. So x minus 3 over example 4 here. Alright, so there we go. We're going to move everything to one side of the equal sign. So greater than or equal to 0. So what we're looking for is when y is greater than or equal to 0. Sometimes it's nice to kind of set that up there so you know what you're looking for here. So you're interested in when your y is going to be positive. Alright, so now we're going to set that equal to 0, and we're going to solve for x. So when we're dealing with fractions, a couple things you want to look at, some important numbers, because you've got two fractions here. So if x is equal to -4 or x is equal to 5, we have undefined, right? And when we have numbers that make this undefined, these numbers are called critical values. And we'll get into what you do with those things later. But right now we know that those are basically our asymptotes because the x value of -4 or 5 make those undefined. So we know that the graph cannot cross at x is -4 or 5. So if you remember, we solved this by multiplying both sides by the common denominator, which is, whoops, that's a -5, isn't it? Okay, and then that gives me an x minus 5 times x minus 3 minus, let's see here, x plus 4 times x plus 2. So it gets rid of my denominators there, which I like. Go ahead and multiply all of this stuff out. So you do the FOIL method there, FOIL method there. I'm not going to do all that. You end up with your x squareds canceling, and you get something as simple as that, and you get x equals 1/2. Okay, so that's the only place that this graph will cross the x-axis. So this is where the critical values come into place. So we use the critical values basically as just an additional interval. Okay, so what we've got here, let's go ahead and put the graph on here. We've got our critical interval at -4 and at +5. And this graph actually looks like this, crosses at 1/2, and then it comes like this. So this critical interval here, are these 2 points are important because we've got stuff going on here, we've got stuff going on here, but because we have a 1/2, so we've got an interval here, an interval here, and an interval here. So we've got basically our 4 intervals. So let's move all of this kind of up and out of the way here, and we'll put our, oops, I'm going to get rid of this too. We'll put our critical intervals, or our intervals in here, negative to -4, -4 to 1/2, 1/2 to 5, our next critical interval, and then 5 to +infinity. Okay, so 4 places. So let's look at our test numbers. So what are our x values? Let's say we put in a -5. Our f of x, or our y value, it's going to kick out a positive 7.7. So it's going to give me a positive number. Stick in a -2, put it in the original problem, kicks out a 2.5, gives me a negative. This one here, they put in a 3, kicks out a positive 2.5, which is positive, and here they put in a 6, 7.7, negative 7.7 is our answer, and it's negative. It will not always be positive, negative, positive, negative. Okay, don't get to where you think that every other one is going to be that way. But yeah, so far they seem to have been. So our intervals are, we're interested in when is y greater than or equal to 0. When is y positive? It's positive here and here. So those are the two intervals I'm looking at. So my solution set is negative infinity to negative 4, and I put a round one here. This is what the critical value says. It cannot be negative 4, right? Because it'll make it undefined. So we put a round one there saying it can go up to negative 4, but it can't cross. And whoops, but it can be 1/2, and it can go up to 5. Okay. Now to put this in set builder notation, you can go ahead and do that if you want, and like I say, it's good to practice that. And if you look at the top of page 326, it gives you a box with the steps in order to solve rational inequalities. In step 4, make sure that you're conscientious of those critical values, because those critical values are going to be part of the intervals that you're going to be doing there. Okay. So that's it for 3.6.